In this video, I will discuss the CNC machine electronics I chose and how to wire them. Hi, welcome to Slow Engineering. I'm David. I planned to use an ordinary 3D printer mainboard as a CNC router control board. 3D printer mainboards naturally have a 3-axis stepper setup. I chose the TMC2209 stepper drivers to provide 32 microsteps on 3 axes, and the corresponding mainboard provides UR mode to control these stepper drivers. Follow the manual instructions to adjust the jumper patterns on the board to set up the drivers in UR mode. Place the drivers into the sockets. For stepper wiring, find the meaning of the color wires from the manufacturer. There is no standard definition of stepper wires colors. The stepper wires come with coil A and coil B. The board has coil 1 and coil 2. Make a quick match from coil A to coil 1, and the positive polarity to polarity A. This will match 4 wires from steppers to mainboard sockets. Most common 3D printer mainboards have defined pins in the modeling firmware. All I need to do is make sure the pins are well defined. Finding a board for CNC application is different due to the spindle output. Of course, the spindle can be operated without assistant control, but if it could be controlled by modeling firmware with a suitable connection, it would be easier to adapt to various situations, like cutting and grinding at an adjustable speed. This mainboard has 3 customizable voltage PWM signals, 5V, 12V, or 24V via a jumper board. The original thought was to connect the spindles directly without a jumper board. But I quickly found out the problem is that these sockets only provide 1 amp. The output current is not enough to power a spindle properly, so I bought another DC motor drivers controlled by PWM signals to fulfill the purpose. It supports 3.3V or 5V PWM inputs as a control signal and provides a continuous 15 amps current with 24V output to power the spindle. It means connecting the CNC fan socket with adjust voltage to 5V to this driver boards to control the spindle is possible. The DC motor driver controls the motor in both directions with 2 PWM signals, with pin enable, pin PWM1, pin PWM2, and pin ground as inputs to achieve 2-direction movement. According to the original Marlin G-code macro, the 2 PWM control might not be supported by the default M3 and M4 commands. Fortunately, the driver can work in the cutting direction without the inverting function. Pull up the PWM2 signal to disable the inverting function. The driver pins enable and PWM1 will be assigned to the 2 CNC fan sockets on the mainboard to control them. On Marlin, pin enable is on pin PB6, which is the socket fan 1. Pin PWM1 is on pin PB5, which is the socket fan 2. For pin PWM2, find another positions that provides 5V and ground, pull them up and disable them. The remaining connections are limit switches. The mainboard only provides a limit switch socket for each axis. That is why I only install a single limit switch on each axis instead of a 3-position setup. The mainboard socket has 3 pins, wiring 2 wires from the limit switch to the signal pins and ground to finish the limit switch connection. For the power supply, I bought a 350-watt power supply with 24V output to power these boards. The DC driver board will be powered parallel to the mainboard. It is good to have them separate to prevent burning up the mainboard. This is the introduction of electronics on my CNC router and its wiring. I hope you enjoyed. If you have any suggestions for this CNC router, please comment below. Like, share this video and subscribe to this channel if you learned something, or consider becoming a Patreon member to support my projects. Thank you for watching, and see you next time.